Hey everyone, welcome back to The Explainer. Today we're diving into something that's honestly kind of wild. We always talk about artificial intelligence in these super abstract terms, right? We use words like algorithms, neural networks, and the cloud. It sounds completely ethereal and weightless. But here's the reality. The cloud is heavily and permanently tethered to the ground. Every single prompt we type requires physical infrastructure. So today we're going to look past the software. We're looking at the real physical footprint of our digital lives and how, literally day by day, AI is quietly draining our Earth's resources.
So here's our roadmap for today. We're going to start with the existential AI threat, move into the accumulative environmental cost, see how it's draining Earth's natural resources, explore the psychology behind our invisible consumption, and finally, look towards sustainable AI practices.
All right, part one, the existential AI threat. So, how will AI destroy the world? When we ask that question, our brains usually jump straight to some sudden, decisive catastrophe. It's that classic Hollywood movie setup where machines become smarter than us, go rogue, and just decide humanity is obsolete. Think Skynet or any thriller where an AI instantly locks us out of our own systems. It's a super compelling, terrifying thought. And because it plays right into our deepest fears of the unknown, it naturally dominates the whole global conversation around AI. And when the CEO of OpenAI actually gets up and openly discusses a lights out for all of us scenario, the entire world stops and listens. And rightly so. We are actively grappling with the genuine possibility of highly advanced systems developing goals that are completely misaligned with human values. We absolutely have to take these extreme warnings about permanent human disempowerment seriously.
But actually, let's step away from that blockbuster movie plot for a second. We need to pivot our focus to the quiet, day-by-day risks happening right under our noses. Researchers divide these threats into two distinct buckets. On one side, you've got decisive risks, that sudden, catastrophic robot takeover that makes for great headlines. But on the other side, we have accumulative risks. And these are arguably way more dangerous because they aren't hypothetical, they are already underway. We are talking about the gradual, grinding erosion of our natural world and societal resilience through resource depletion.
Which brings us right to part two, the accumulative environmental cost. Think about this for a second. AI development isn't just someone sitting there writing smarter code, it requires a physical exponential explosion in computing power. Over just a 6-year period, the compute required to train the biggest, most advanced AI models didn't just double or triple. It skyrocketed by 300,000 times. That is an almost unfathomable increase. And guess what? All of that hardware requires electricity. Massive, unprecedented amounts of power that, let's be real, are still primarily generated by burning fossil fuels. 626,000. Just let that number sink in for a moment. That is the number of pounds of carbon dioxide emitted just to train a single state-of-the-art language model. When you ask a chatbot to write a clever poem or summarize a massive email thread for you, you are tapping into a system whose very creation required a monumental burn of carbon. To put that abstract number into perspective, think about the lifetime emissions of 5 average passenger cars. That's from the day they leave the dealership to the day they're scrapped. Or picture 300 round-trip flights between New York and San Francisco. Or 125 flights all the way to Shanghai. That is the massive environmental price tag of teaching just one model how to process language. And tech companies are constantly training, refining, and deploying hundreds of these models every single year. Moving on to part 3, draining Earth's natural resources. So, by 2030, the data centers powering all this AI are projected to consume 945 terawatt-hours of electricity every single year. That number is absolutely staggering. It's practically double their current usage. To really wrap your head around that scale, 945 terawatt-hours is roughly 3 times the combined annual electricity consumption of Pakistan, Bangladesh, and Nigeria. This is a massive strain on our global power grids that could literally force us to delay retiring old, dirty coal and gas plants just to keep the internet running. And the scale of this consumption extends way beyond just electricity. The physical footprint is massive. We're talking about land usage reaching 14,500 square kilometers. That is equivalent to 12 New York cities, just paved over 4 data centers. Plus, we're looking at generating up to 2.5 million tons of hazardous e-waste annually as the servers burn out. And honestly, perhaps the scariest part, up to 6.6 billion cubic meters of fresh water will be withdrawn by 2027 just to keep these massive server farms cool. And a lot of times, this happens in places already facing severe droughts and water rationing.
Now look at the geographical split here, because it reveals a deeply unequal system. The US and China hold about 90% of the world's computing wealth and infrastructure. Yet the environmental burden, mining for critical minerals, the land devastation, the toxic e-waste, that's frequently shipped to or extracted from developing nations. It is a stark geographical imbalance. A few places reap all the technological rewards, while the rest of the world absorbs the ecological risk. But here is the most surprising fact, and it brings this whole issue right to our front door. It's not just the tech giants to blame. 80 to 90% of AI's total energy consumption comes from everyday user activity. It's a process called inference. That means every single time you or I generate an AI image, ask a chatbot a quick question, or use a predictive feature on our phones, we are the ones actively driving this massive energy demand.
Okay, part 4, the psychology of invisible consumption.
So, if we're the ones driving the demand, why aren't we all freaking out about it? Well, because the physical damage happens far away in these remote, windowless data centers, we experience what economists call a tragedy of the commons. Think about it. When you leave a heavy appliance on in your house, you eventually see the cost on your own electricity bill. But when you run 100 AI prompts, that energy is burned hundreds of miles away. You don't see the smokestack, you don't feel the heat from the servers, and so we just kind of recklessly exploit the invisible internet. Recent research published points out that overcoming the psychological distance is our very first major hurdle. We suffer from this severe disconnect between our digital actions and their physical consequences. Bringing education about our digital footprint into schools and forcing radical transparency from AI companies can really help bridge that gap. If we want to change behavior, we absolutely have to make the invisible visible. Which brings us to our final section, towards sustainable AI practices.
Now, for the good news. AI destroying the Earth is not some predetermined fate. We can actually manage this through smart policy choices. Just like we have rigorous standards for food safety or vehicle emissions, we desperately need standardized, transparent metrics for computation. We need PUE to track power usage effectiveness, CUE to monitor carbon emissions, and WEU to minimize water waste. These are the exact metrics that governments and independent watchdogs need to use to audit these massive facilities and hold corporations accountable. By implementing things like carbon labels, enforcing transparent audits, and transitioning to renewable resources, we can dramatically shrink AI's footprint. Just imagine if, right next to the Generate button on your favorite AI tool, there was a tiny carbon label showing the exact environmental cost of your prompt, kind of like calories on a restaurant menu. It would immediately change how we interact with the technology, and it would push companies to build highly efficient, green-certified infrastructure powered by solar and cooled by recycled water. This technology is absolutely incredible, and it holds immense potential to solve huge global problems. But its cumulative cost to our climate, our water, and our land is undeniably real. So the ultimate question we have to answer is this: will we choose to build an AI future that benefits society without causing irreparable damage to the Earth? The next time you type a prompt into the cloud, remember the physical Earth that's powering it. Thanks so much for exploring this with us on The Explainer today.